Okay, so we're going to be talking about the basically bone tissue, and the skeletal system today. We're not going to go over the anatomy of the system itself, but we're mainly going to talk about the physiological aspects of it, and then also kind of think how things are developing and things to that extent. Okay, so we all know that bone is living tissue until it becomes fossilized, right? Yes, no, maybe. You guys start off as little kids and then don't you guys grow?
Yeah.
Yeah, yeah, okay. And so your bones actually kind of develop with you as you grow and everything. To that extent. So what are your bones for?
Keeping structure.
Structure. Okay.
I know the bone marrow is where some white blood cells are made, I think.
That is correct.
Let's see. I know our muscles use it to stay connected in place.
Okay. So support for the muscle. Okay. Anything else?
Like the ribs are protection.
Protection. Okay. So you guys just basically did my first 4 slides pretty much for me. Good job. Okay. So yeah, exactly. So the bone basically serves a couple of functions, right? Like you guys say, it's for that support. It also provides structure. It allows us movement, right? It helps with the movement aspects. It does protection. And then, as you said, bone marrow is responsible for some of the production of the red blood cells. So hemopoiesis. Hemopoiesis. I can't even say it now. Hemopoiesis. I'll spell it out here in a second. But okay, so here basically we're just showing you it's like it's going to be important for supporting movement, right? So those movements of muscles and stuff, we need our bones there, and then those muscles need to be attached or joined to those bones to sit there and allow for movement. We also have, you guys are seeing my slides? Are they showing?
Yeah, I see them.
Okay. So we also know that in the case of the cranial structure, we use it for protection of the brain and things like that, or like our lungs, we use it for the protection of our lungs, our rib cage. So we also serve as a protective space. In terms of that structure, we also, it serves as a structure. Sometimes we have to, like when we break a bone or something like that, we need to reinforce those structures. And so we may need a brace or a cast for that particular moment. Right? And as you had mentioned, the marrow, the bone marrow, which is made up of 2 components. We have the red marrow, which is where your hematopoiesis area. Hematopoiesis, where hematopoiesis actually occurs. I knew that word was in my head somewhere. So hematopoiesis, where red blood cells, where you start to form some of your blood cells. So we form our T cells, our B cells, our monocytes, some of our macrophages and things to that extent are all formed in that red marrow. Okay. The white marrow basically is going to be used for fat storage. And so it has a lot of that fatty tissue and stuff in there for it. Okay. So bones are basically classified often by their shape. And so we use the shape to sit there and help us with the classification of the bone, like the long bone, right? The femur, the sternum, the flat bone, irregular bone, the vertebrate bone. So we use the shape to sit there and help us in terms of those classifications. We also know that bone's function is going to be dependent on its location. which ligands or ligaments or tendons are attached to it, where and if blood vesicles are penetrating, where the nerves are going to be at. So that all plays a point in terms of understanding the function of the bone itself. Okay, so this is basically a cross section of a bone. And so these are all of the bone cells. So there are 4 bone cells in bone tissue. So we have the osteocytes, we have the osteoblasts, we have osteogens, genetic cells, and we have the osteoclasts. Okay, so the osteocytes, let's see. So the osteocytes, basically, they're responsible for maintaining bone tissue. Osteoblasts, they basically form the bone matrix. The osteogenics, those are basically stem cells. So those cells they can be transformed into the other forms of bone cells. And then we have the osteoclasts. The osteoclasts are the osteoclasts are responsible for reabsorbing bone. So, so they partially help with that calcium regulation. Sorry. Okay. So osteoclasts are basically, they're going to be developed from monocytes and macrophages. And so they're actually going to appear a little bit different than the other bone cells, where the osteogenic cells basically are responsible for the development of these two. Okay. Questions, concerns? Cash.
Good.
Okay. Come on. Okay, so this is actually a cross section of a compact bone. And so you can kind of see the detailed intricacy of it. So here you can actually see different structures. You can see the nerves, you can see the vessels, you can see the trabecular. You can see here basically is the spongy bone down here. And then, of course, that is our compact bone. And then you can also see those vesicles, the lymph node system that are going through there as well. And so the bone has a lot of intersections of different systems. So you have the lymphatic system, you have the circulatory system, you have the nervous system that are all being integrated into this matrix. So it has a lot of complexity to it, but there also needs to be some space for these things to be actually integrated so that they can get in there significantly. Because we know that, like in the middle of our bone, we need to have that bone marrow, and that bone marrow, like you said, are responsible for producing a lot of our blood cells. Okay, so we need access to the blood vessels so that we'd sit there and be able to put those cells in the area that they need to be in. And it kind of is a cool little system if you think about it, because like in the middle of the bone, for the most part, is where you're going to have that marrow, right? So it's kind of like a protected shell where you can actually generate all those blood cells that you sit there and need to be circulating in the body. And then you have these tubes that are integrating directly into it. So you have an easy on-ramp into those highways, those blood highways. So okay, so here, this is a diagram of the spongy bone. So let's see. Spongy bone is the component. So at the end, we have like a cartilage and stuff like that. At the end of that, we have what we call that spongy bone. Have you guys ever had chicken? You guys eat chicken?
Then when you like bite into it, there's that one squishy end.
Yes, yeah. And it has all of that great tasty marrow and stuff in it after,
Yeah.
delicious that you often will use for soups and stuff, right? So if you look at it, we break it down and you can actually see the red components here. That is actually the marrow of it, okay? So you can actually see the marrow in it that is filling up those cavities. So all of those empty cavities, it's all going to be filled with that marrow, okay? So is basically going to have your never say this, trabecular, there's no R, trabecula. The trabecula, which is going to basically contain your osteocytes. Okay, so these here are just those structures, and so you're going to have that little matrix that are going to be formed, right, from your osteocytes. And so this is just another section of it, so you guys can kind of get an idea of the structure itself. Okay. Let's see. So this is an example of an individual that has deformation or a disease called Paget disease. Paget disease, basically, the individual is kind of bow-legged, and they so their legs or their bones are really curved, and they're also very porous. Okay, so these individuals, can you guys see the difference between here?
Yeah.
Yeah. So these individuals, basically, they're going to have very brittle bones, so they're going to have issues with bone breakage and things like that. They can't get too heavy, because then that weight can cause major impact on them, since it's very porous. Now, if we look at it, the bone isn't too thick in the first place, and we kind of have a look here. We have all that sponginess, right? So that sponginess, instead of like how is rather than just being at the tip of the bone, it actually is going throughout the bone, kind of making it all kind of very, very porous in this sense. So it's gonna end up causing, but the only thing is that you're not gonna have as much marrow and stuff like that to adequately satisfy those regions. And so you're not getting that cushion that's going on with it. You just have that really light porous bone, okay? And because of that, the bone is brittle. It's wear out a lot more than a normal individual. And so you're going to end up, again, as I said earlier, with a lot of breakage. You can't have issues of being overweight or anything like that, because of those major issues as well too. And so this disease is, so there's a component of that is thought to be a genetic aspect of it. There's also a virus that actually causes this. However, they haven't been able to isolate and truly identify the viral component. They just see it in individuals. One point they're nice and healthy, and then all of a sudden they start, as they grow up, they get some type of infection, and then this ends up happening. So. So we've talked about like the blood vessels and then the nerves that have to be going into the bone itself. And this is just basically just kind of showing you that and showing you like how everything is kind of interwoven, right? So you have your blood vessels, so that's your arteries and your veins that are both entering and exiting the bone. And it's essential that you have these guys, You have places where new blood cells could actually go into the bloodstream. And it's also so that you're getting nutrients being delivered as well. And so why do we have nerves in our bones?
I would assume so we can know if we break them.
Yeah, so we can know if we break them or if we hit them really hard on something, right? What happens when you hit your funny bone?
Pain.
A lot of pain. I'm notorious for hitting the bottom of my bed. So I have a little base that's wider, my bed frame. My bed frame is actually wider than my bed itself, and I always cut it short when I try to go to the TV or something like that. And I always hit my calf on it, and so the front part of the calf there's not that much muscle. There's a whole bunch of bone there, so I always feel it. Okay, so there are basically 4 steps for intramembranous ossification. So one of the very first steps is that your mesenchymal cells, they group in clusters. And so you get the clusters that are actually forming on the outside here. And then in the middle, you're going to have your osteoblasts and your osteoids. So your osteoids are basically they're vesicles that are secreting uncalcified matrix, and so it's still kind of soft. It hasn't gotten formed completely, and so you have those little dots there. Let me see, or vesicles right outside of it. Okay, now the osteoblasts are actually doing the secretion of that. And so that's going to actually start working on forming your matrix. Okay. And then after the we'll see. Sorry. I don't know how I get that on my screen. Okay, so then, as I said, your osteoblasts are gonna actually start getting trapped because of the secretions that are forming, and then so that uncalcified parts is going to start becoming calcified. And so that's what you see here. And so these osteoblasts are going to end up becoming osteocytes. So then they're going to change their form. Okay, and then these osteocytes are then going to be responsible for making more and more of that matrix, and then kind of interweaving itself. So then you'll start getting your trabecular formation, and you're going to get more and more superficial development of that bone, and your blood vessels, they're going to actually condense into your red blood marrow. I mean, your red marrow, and so then that's going to actually act as that marrow that's going to be filling in that area. Come on. Okay. So that's that inner membrane component, right? So, and if we look at the endocrine ossification, so that one basically is going to be 5 steps. So the mastocytic cells will differentiate into chondrocytes, and then the cartilage model is going to basically be it's going to be the future part of the bony skeleton, and then it's going to be and it's also going to be the pericardium forms. So can't really see so this here is going to be your pericardium, and so you're going to get that formation, and then and so after your perium, so the capillaries are going to be penetrating the cartilage, and then your pericardium is going to actually change to the periosteum, and then your periosteal collar is going to basically develop, and then you're going to get your primary ossification. So this is your primary ossification center right here, and then you guys will notice that there's spongy bone that is forming around it, and as that continues, excuse me, you're going to have your secondary ossification centers starting to develop. And then you're going to start getting more and more blood vessels that are going to be moving into the area, and then forming that nice little matrix, so that makes sure that we get the blood that we need within the bone itself. And then towards the end, you're going to actually, so this was our primary, here's our secondary going on, and then towards the end, we're going to actually get the cartilage that is going to be remaining at the growth plate or the epithelial, the facile growth plate, and then right at the joint surface. So right up here. And so, like, you know, when you guys were talking about, when we're talking about eating the chicken bone, like a chicken leg, but at the very end of that chicken leg where it's been broken, so you have the cartilage area, so you have that big aspect of cartilage, right? So that's your articular cartilage right at that point. Okay, questions?
This all happens during while you're growing up, right?
Yeah. So, and I should also say, so the one thing that I do want to add, so while you're growing, you're developing and stuff like that, you're going to be constantly, so this is this is before you're a fully developed individual, these first aspects of it, right? But later on, so this cartilage is going to be regenerated when you're youth. And so as you grow and you start to get bigger and bigger, you're going to get elongation. We'll talk about bone elongation here in a second, because there's not much to bone elongation. That cells expansion, you get more sites, and then you start forming more ossification that's going to be occurring internally and stuff like that. And so you're going to get the bone itself that's going to elongate. But the thing is that cartilage at the end, right? So your cartilage that's developing, that's going to grow a little bit. So it's going to grow up into your, like, let's say, late teens, early 20s. And then you're going to start getting less and less growth in that area. So if you tear it or if you rip it, it's going to be gone. And so as you start hitting your 20s, that starts to affect that cartilage growth. So those joints starts getting stiff. Part of the reason you start getting swelling in your knees and stuff like that is because you're getting cartilage that is being ripped and it's not being replaced or repaired. Okay. So but all of that is going to be done when you're, so that first part, you're going to have it while you're young. and then you're just going to develop more and more, and you're just going to get what you call growth zones, and you're going to get elongation of the bones. And so this is just basically showing you the longitudinal bone growth. So as we develop, this is what happens. And so you'll have areas that are going to start to grow. So usually the growth area is going to be that first end. And so if you kind of look at how this is set up, so you're going to get your ossification. You're going to have some dead cells that are going to be existing. And then these guys are going to be your mature cells. Now in this area, you're going to have a lot of your matrix that are accumulating. And you'll notice that within this matrix, you're also going to have a lot of fat, so lipids, structures. You're going to have some glycogen because you need food and stuff, that food source, that quick food, that stored food. You're going to need signaling molecules. So alkaline phosphatase is known to accumulate in this area because it's responsible for sending signals. Okay, you need to grow. You need to grow a little bit faster and stuff like that. Especially, you'll see high activity of alkaline of the phosphatase. So you have what we call you have kinases that phosphorylate things, and then you have phosphatase that removes that phosphorylation. And so those are like your on and off switch. And so you'll see these on and off switches accumulate within that area because it's the point of growth. Okay, does that make sense? Are you there?
Oh, my mic was off. Yes.
Okay. Yeah. So so like I said, phosphorylation serves as like an on and off switch for things. And so the area that's responsible for it is going to be that epiphyseal plate, so that the very end. Okay, so that's going to get our extended growth, and so it's just going to run onward. So some of our older cells are going to be towards the bottom, and then some of our newer cells are going to be more where the joints are. And that kind of, you know, it kind of makes sense in a sense, you know. So if you look at it, that part at the top, you're going to get the most growth. And so let me show you now. So this is where your growth are going to occur at. And so it's going to be pushing that stuff towards the middle, right? And so, but if you think about it, so since this guy here is going to be new growth, and this guy here is also going to be new growth, and it's going to be pushing everything out towards the middle. So your oldest growth is going to be where?
Oldest growth is going to be in dead center.
It's going to be in the center, right? And so if you think about where do a lot of fractures occur?
Oh, okay. Because that's where they're the weakest, because they're
Yes,
so old.
They're older, yeah. Okay, so, and that brings us to that next part, fractures. Come on now. Okay, so there are 8 types of fractures. So the first fracture is called a closed fracture. Okay, so now a closed fracture is basically when you get nice clean break, but it doesn't get pushed out of the skin. Okay, so it's just kind of still intact and things like that. Well, not intact, but it's still within the skin itself. An open fracture is when you kind of open up the skin, and so your bone is actually protruding from the skin. Okay. And in this case, that's going to cause a lot of issues because now you not only by you fracturing, you're breaking your blood vessels, you're messing some veins, some blood vessels and nerves, and now you've kind of broken skin in addition to it. So it's going to be a lot harder to repair on its own. It's going to take more than just you. You got to get it realigned and all that good stuff to sit there and allow for it to repair. And it would also probably require some stitches as well too. So then we have what we call the transverse fracture. So transverse fracture is when you're getting impact on both the bottom and the top. So like an impact happening both ways. So resulting in the bone being pushed together and causing a break, right? In this context, you have a nice little fracture, but it's still kind of confined. There's some issues with that because a lot of that inner part isn't broken. And so you're not going to have good hematoma formation, which is going to allow you to sit there and start doing some repairing and stuff like that, and that clotting to happen nicely. So it takes a little bit longer to repair things, those type of fractures, because it's just impacting on itself, and you're not doing those clean breaks where you're breaking those other things. And I'll show you why that's going to be relevant of breaking, your blood vessels and stuff like that. You can have a spiral fracture. Spiral fracture is it's more of, again, you're breaking the outer rim and you're getting, that's more of a twisting sensation. So it's kind of like a snapping sensation or a twist. So it's like shear if you think about force. The comminuted fracture is basically, it's going to be fragmented fractures, the little pieces. So you're breaking it up into little pieces, and so you have nice little pieces that exist there. And I don't know how this one how I keep drawing on that spot every time. But the next one is when you're getting just an impact. So in this case, you're getting breakage because you're impacting in one direction only. So like you step down really hard and it just snaps, or you step down off a thing and you step wrong and you snap. So that's going to be an impact fracture. Then we have a green stick fracture. Green stick fracture is where you don't necessarily break it completely. You just chip it on one side or something like that. So you have like chips that are removed. So, and that's kind of shown here. And then the oblique fracture is also kind of like it's a clean break, kind of like a closed fracture, but it's just the angle that the break is at. So the angle is not a 90-degree angle, and so it has like a little tilt to it or whatever. And so in that case, it's a clean break. So what's going to happen in that situation? That one's kind of going to heal kind of nicely. I'll show you an example, because you have it kind of grafting on itself. Let me see. With the space to actually graft. Yeah. Okay, so the stages of repair of these fractures, there are going to be like 4 stages. So the very first stage is a hematoma, and you're going to get a hematoma that actually forms. So because you broke those blood vessels, blood is going to be pouring in there, and they're actually going to start swelling up to be a nice swelling. You're going to get clotting that's going to be happening. So that clotting is essential for it to happen, for repair to start happening. Okay, so then after your hematoma forms, you're going to start forming what they call the internal catalyst and the external catalyst. You're going to get new blood vessels that are going to be developing now, that are going to replace the blood vessels that were snapped in that situation. You're going to have you're going to have spongy bone fibula that are going to be there. So they're just going to be like, it's going to be kind of like fragments of a spongy bone that are going to be acting as nucleation sites for growth. And so you have all of the cells that are in that spongy bone, and so they're just going to start growing and growing and nucleating. So it's going to start doing patchwork and making a new matrix in that area. Okay. Questions, concerns? Cash?
This sounds a lot like how people get taller with a knee or leg fracture surgery.
Yes. Yeah, that it is in the sense how they'll do it, because it's the same way you break the bone, and then they'll space it out so then they can get a certain height. And so, but they can't space it out too far, because if it's spaced out too far, then you don't get the right size hematoma to sit there and fill in that matrix. So it's really hard for it to do so much. So there's limitations to that. But that's actually cool. That's a good analogy, a good example or application of this process. Okay, so then we have the spongy bone catalyst. I mean, the bony catalyst of the spongy bone actually forming. So you're just basically getting tons and tons of matrix filling up in there. And then you basically have the heel fracture, right? And it'll look a little bit different, but overall, if you have a nice break, it'll actually heal fairly well. The only thing is that as we age, that process gets a little bit harder for us to do, right?
Mm.
Okay, so then we have, we know that we need vitamin D. Vitamin D serves as it's one of the essential roles for calcium that facilitates calcium absorption from our small intestines. And so, and then we have calcium reabsorption from the kidneys, and then all of that's going to be needed for building that bone tissue. So we need that calcium for building the bone's tissue. So one of the major sources of vitamin D is the sun. So we should be getting, a healthy individual should be getting a little bit of sun, not too much sun, because too much sun will actually cause melanomas, and we don't want that to happen, or forms of skin cancer. So we want to try to prevent that aspect of happening, but we want to make sure that we get a little bit, because then it'll help us produce that vitamin D that's needed. The other ways, what are other ways that we get vitamin D? I'm doing all the talking. Food, yes. So we get a lot of it via food or supplements. And so the thing is that the vitamin D that we get through food and supplements, there's going to be only so much that our intestines are going to be able to absorb. And so it's kind of good to sit there and get it from other sources, such as the sun itself, because then the skin is going to be manufacturing it, and then that's going to be utilized in our body. And so it's going to be more readily available from the skin than what it would be from that absorption, because that relies on, again, our intestines absorbing it first. Right? Okay, so this here is basically it's a graph that shows you the relationship between age and bone mass. Okay, so and if you think about it, it makes sense. So as we age, as we get older, so we're like little itty bitty kids, and we grow more and more. We need more and more bone, and then we get to the point where we start growing. Right? We reached our maximum height. So in that case, we start to plateau, and so typically you get that stop growth. Our peaks are going to exist here. So for men, we start getting it around in our late 20s, mid to late 20s, and then females around the same thing, right? A little bit more maybe in their case, right? And then we get to the point where our mass starts to drop. So why does our mass drop as we age? Our bone mass.
Production slows down.
Production slows down. Yeah, so in a lot of ways, it's one of the things we start doing, we start misregulating that calcium, and that's going to affect it as well. So our body starts to age. Our body's not as effective. Well, first off, it's not growing anymore. We've kind of reached our peak, and we're good to go. We also our body starts to age a little bit. Our intake, we don't process food as well as we did when we were actually growing. Your body says, well, you really don't need it so much, right? You're getting a little bit older now. You don't get around as much. You're not running around or exercising as much. You're not breaking as many bones, right? So, or maybe not yet until you get a little bit older, then you're breaking a lot more bones, right? So in that context, then our body starts to, age. So that mass, that bone mass, is going to start decreasing with age. Now, women, they have this huge dip, and that dip is associated with menopause. So there's also the aspects of hormones. Hormones play a part in it too. So when we're young, we have those growth hormones that are, you need more bone, you need more bone, you need more bone because you're growing, you're constantly growing, you're constantly growing. Then you get to a point where you don't need those growth hormones anymore because you've reached your peak. So your growth hormones drop significantly. And so then we start, as men, we start decaying, but not to the extent of as women, because then also their sexual hormones kick in as well too. Ours does too, but not to the extent as women. Okay. So, and then as a result, they get into menopause, and then they get that drop. And then they start like leveling off in terms of decay, just like we do. So, does that make sense? So, you have a couple of, see if I can spell things right. So we have those growth hormones. So, which are going to be important for increasing the length of your bones, and they're also going to improve bone density. We have thyroinics, thyronin. So this basically is going to stimulate bone growth and promote synthesis of that bone matrix. And that one is going to actually be generated by the thyroid. We have, of course, sex hormones. So when we're young, this is going to basically promote the osteoblastic activity, and then that's going to also produce that bone matrix. And that's going to be responsible for like our growth spurts. So like when we start to, get a little frisky and those sex hormones start elevating and stuff like that, we're going to start, our growth spurts are going to be kind of simultaneous with them. Okay. And so we're going to get bones happening at the end. And then for females, when they go through menopause, they actually also produce hormones, and that's actually going to drastically reduce that bone development as well. Okay, because then, and what do you think a female like going through menopause will result in will result in a drastic drop in bone loss? What?
I was gonna say, don't they go through like major heat flashes?
So they go through major heat and cold flashes, yeah, during menopause. There's one thing that definitely like happens in menopause. It's kind of like a signature thing. And it's like, hey, that's it. You don't have many more opportunities after that.
Oh, there's no more eggs, right?
Yeah. Okay. Exactly. So they no longer start producing eggs. And so as a result of that, it is simultaneous with that you are no longer needing to produce a child, right? And so you're not going to have to bear a child, so you don't need to sit there and have strong bones in that circumstances. You don't need that extra mass or that extra support, because you're not going to be carrying a child.
That makes sense.
Okay. So then we have calcium-trimol, which basically it stimulates the absorption of calcium and phosphates from the digestive tract. And then we have parathyroid hormone. So your parathyroid hormone stimulates the osteoclasts, which are responsible for the breaking down, and the reabsorption of bone. And so in that case, you're breaking down that matrix, and then so you're really kind of releasing calcium in that situation. And then that allows calcium to be reabsorbed by the kidneys, kidney tubules. And then it also, as I said, indirectly increases calcium absorption in small intestines. And then we have calcium which basically inhibits osteoblast activity and stimulates calcium uptake by the bones. Put this here for right now. Okay, let me clear. Oh, damn it. I did it again. Let's see if I can get this to work.
Control Z.
So I keep hitting. It just doesn't want to reply. Let's see. There we go. Okay. Let's see. Okay, so in this situation, this is basically a calcium homeostasis. So this is the pathway for calcium homeostasis. Okay, so here we have our thyroid gland. So our thyroid gland is going to release that calcium tonin, and then the calcium tonin is going to inhibit osteoclasts. So that basically means that we're not going to be breaking down the bone, and so you're not going to get calcium being released in this situation. So you're not going to get more calcium in the bloodstream. You're actually going to have a decrease in calcium in the bloodstream, and the calcium is going to be reabsorbed in the kidneys, and then you're going to basically have a decrease of calcium in the bloodstream as a result of that. Now, in the other way, for normal calcium, so then we will actually get, so this guy results in an increase in calcium levels, and then this guy was going to result in a decrease in calcium levels. So if calcium decreases, then the parathyroid gland is going to release the parathyroid gland is going to release the parathyroid hormone, and then that's going to cause or stimulate the osteoclast cast to release more calcium from the bone. So it's going to be breaking down more and more bone, because those guys are going to be stimulated, and then the calcium is going to be reabsorbed from urine by the kidneys, and calcium is going to be absorbed into the small intestines, which is going to increase the vitamin D synthesis, and so you're going to end up with more calcium in your blood as a result of this. So if your calcium levels are increased, you're going to end up getting decrease in calcium by this pathway. If your calcium levels decrease, you're going to get an increase by this pathway. So it's going to end up balancing it out. Does that make sense?
If the kidneys are absorbing calcium, could this lead to kidney stones?
Yes, and it does lead to kidney stones if there is too much calcium to absorb. And so often when we age, this this homeostasis gets screwed up. So, you know, the older we get, the probability of us having kidney stones are more probable, right? Because we no longer regulate at the level that we did when we're in our teens and, and 20s. Yeah, but that's a very good point.
Okay, thank you.
Okay. Anything. So that is pretty much it. Do you guys have any questions?
We have a physical lab this Wednesday, and today we have, is it an EX lab or?
Yeah, you guys are going to have a physio X lab, but they're going to be both posted Wednesday, but they're not going to be, so like normally how I have one due, they'll be due Friday. All your labs are going to be due next week. So you'll have a week to sit there and get them done, but we're going to be able to do the physical lab on Wednesday and get it done. But then you're also going to have a physio X lab due as well. So,
Okay.
okay. Yeah, and I'm not giving it to you yet because we haven't gone over the topic yet. So,
All right.
okay. So just right now, relax. And I'll try to have everything. I'll be sending you guys emails. Like a lot of my paperwork will be done this week. I'll be completing it because it has to get done by the end of the week. So because of that, I'll have less outside work to do with building my programs and stuff like that. And then so I'll have more time to spend with you guys and focus on getting you guys to where you need to be at the end. So you'll get a little more response from me and a little more direction as well. So, okay. Are there any questions?
So
Okay.
that's about it for me.
Okay, sounds good. I will talk to you guys later.